So what have we got here? We've got 5.05 grams of phenylalanine. Well, we know what phenylalanine is. It's like this. There's 1, 2, 3, 4, 5, 6 carbons in a ring. Every carbon here has got a hydrogen on it. So there's 1, 2, 3, 4, 5 hydrogens, an N and 2 H's. So you've got 6 times 12 for the carbons, 1, 2, 3, 4, 4 times 1 for the hydrogens, and you've got 14 for the nitrogen and 2 more for the 2 hydrogens. So you can work out the MR. The MR of phenylalanine comes out as 93. So I've got the mass of phenylalanine 5.05. So moles is mass divided by MR. I've got 0.054. I know that from here 1 mole of this makes 1 mole of this. So 0.054 moles of phenylalanine should make 0.054 moles of the product, theoretically, if there's no waste. Now, the MR of the product, the purified product, in step 1, I can work out the MR of this. So 6 carbons, 12 each, 5 hydrogens, 1 each, 14, a 1, a carbon is a 12, and oxygen is a 16, carbon is a 12, and 3 H's are 3 1s. And it comes out to be 135. Now it tells me that the amount of product that's made is 4.82 grams. Well, if I convert the mass, if I know the number of moles of product that I make, which is 0.054, which is the same as the phenylalanine, I can, moles is mass divided by MR. I've got 135 as my MR. I can work out the mass, which is 0.054 multiplied by 135. 7.33 grams should have been made. I've only made 4.82. So my yield is how much I did make, 4.82, the smaller figure usually, divided by 7.33 multiplied by 100%, 65.8%. Write an equation for the reaction of this intermediate in step 2. So let's have a look at step 2. So in step 2, I've got an NO2 joining onto the ring. So here, in step 2, I've got an NO2 joining on the ring. This part isn't changed. To get an NO2 joining onto the ring has got electrons in it. It attacks positive species, so it makes NO2+. I get that, by the way, NO2+, from reacting concentrated sulfuric acid, H2SO4, with concentrated nitric acid, HNO3, and it makes NO2+, and water, H2O, and HSO4- ions. But I've got an NO2+ now, and it will join onto the ring, and it will release an H from the ring, and that will be plus. So the plus is transferred onto the H, as the H has been replaced. Name and mechanism. Well, this is an electrophile. It's an electron pair acceptor. It's going to accept an electron pair from the ring when the ring attacks this. So it's an electrophile, and it's replaced the H on the ring. So the NO2 has replaced the H. It's electrophilic substitution. Suggest the type of reaction occurring in step 3. Let's have a look at step 3. So step 3, what's step 3 done? Right, it's broken that bond there. NH2 has been formed from NH2COCH3. That's an amide bond, or a peptide bond that's been formed there, an NHCO. That peptide bond, or that amide bond, has been broken. Well, when you make an amide bond between an amine, an NH2, and a COOH, a carboxylic acid there, it releases water. You can put the water back in by reacting water with it and with a little bit of dilute alkali or base, OH-, acts as a catalyst. I can replace the water back into that bond. So when I've made that bond, I've released water, condensation reaction, and when I put the water back in, it's called hydrolysis. Hydrolysis means using water to break bonds. Identify the reagents used in stage 4. Let's have a look at stage 4. Stage 4, I've turned an NO2 into an NH2. Well, there's two ways of doing that. To replace the O's with H's, I can either use hydrogen and nickel catalyst, or I could use tin and concentrated hydrochloric acid. Hydrogen nickel is probably the easiest one to remember.